see the slides?
Yeah.
Great. So first, good morning, everyone. I hope you're all doing well. And I want to say sorry about early morning lecture. It wasn't my idea. So first, let's quickly look what you learned on the previous lecture. Maybe you have any questions left, and then we will proceed. So I believe you learned more about functions. Yeah, functions. Then you look through the collection types, arrays, dictionaries, and sets. Also, you learned more about closures, your running time, hashing, and that's pretty much it. So does anybody of you have any questions on the topics which you learned last time?
For now, not.
Okay, so but if you have questions anytime later, just go for it.
Yep.
Sounds good. And then we can start with the initialization. Yeah. That's not what I wanted to do. Yeah. So you actually already used initializers when you created an instance of a class or a structure. Initialization, it's pretty much a process of preparation of your instance to be used. The important rule of the initialization is that all the properties of your class or a structure have some value when the initialization is completed. So there cannot be any property which is in undefined state. Yeah. First, you either need to provide a default value for your property, or you need to set this value in the initializer. Initializers, it's pretty much a function with some really specific syntax. So you need to use init keyword, and then you define it exactly the same way as any other function. You can have 0 or more parameters, and then you have a body, just like a normal function. Yeah, as I said, initializers can have parameters. For example, here we have Celsius structure to represent temperature. As you see, there is a property for that. And there are two designated initializers to set this value in different temperature scales. So as you see, right in the body of the initializer, you can actually do all the conversions to the, so for example, from Fahrenheit to Celsius or from Kelvin to Celsius. And when you use it then later, you can use either one of the initializers. And this way, you are making sure that all the properties have value when the object is created. And if you have multiple properties, for example, and if you forget to set a value to some of them, compiler will let you know. So compiler will make sure that each initializer completes in the valid state for this instance. Also, you can get a default initializer provided by Swift for a structure or class, base class. Base class in Swift is the class which doesn't inherit from any other class. Unlike in Java, there is no universal base class like object in Java. So in Swift, if a class doesn't inherit any other class, it is a base class. And yeah, default initializer will be provided if you do not define any other initializer yourself, and if you provide default values for all the properties. So, for example, if we go back to this example with Celsius, there is no default initializer provided. First, because we have two initializer declared ourselves, and there is no default value for the temperature. For example, if there was no other initializer and we would put here, for example, 100, then we would have just empty initializer like that provided by Swift. So we wouldn't even need to write it. And you can also get a member-wise initializer for structures. So for Celsius, you can also get a member-wise initializer. Again, if you don't provide any other. For example, like in this example below, you have a structure for user with first name and last name, and you don't provide any initializer. Then you can create a user instance just like that, providing value for each property in this order from top to bottom. Yeah, it's not necessary to have default values, but you can. You still will need to provide them here. And yeah, I can actually quickly show you what you can do with the initializers. So for example, you have a class, let's say cat. Say next number. So right now it won't work this way because it will tell you that you need to have initializer because there is no default value for this property. And yeah, let's do it. So the compiler will always make sure that all the properties have some value. Otherwise, this state would be invalid. This way it's fine. And then we can, for example, declare a variable and use the initializer. So to use the initializer, you just put a name of the class or a structure, and then you use around brackets. And if there are any parameters, you provide values for them here. So like any other function, but with the class name. We can also provide another initializer, for example, without parameters. But if we leave it empty, it won't let us do that because then if you invoke this initializer, it means that the property doesn't have a value. So as you see, you will get an error that you return from the initializer without initializing all stored properties. This is the stored properties. We will look into different types of properties a bit later. And let's say the default one would be 4. Yeah. And then here you can use either one of them. This one would be valid too. Yeah. And let's make structure out of it. And remove the initializers. As you see, we can use member-wise initializer provided by Swift. So if we have more properties here, it will ask us to provide all the values. Yeah. And let's probably go back to the slides. I think I showed everything. Mm-hmm. So there are two types of initializers in Swift for class types. Designated initializers and convenience initializers. And designated initializers are the primary ones. So the ones which we used here, let's go back a bit. So these are designated initializers. They're supposed to fully initialize all the properties introduced by the class. So otherwise compiler won't let you proceed. Yeah, it calls superclass initializer if a class is subclass. So when you have two classes and one inherits another one, the superclass is the one which is inherited by the subclass. Normally, it's very common to have just one designated initializer, but can be more. And every class must have at least one designated initializer. Oh, something went wrong here. I'll put a picture of it on top. So yeah, it needs to be the one provided by Swift when all the properties have a default value, or the one which you write yourself. Convenience initializers are secondary. They are optional and you don't necessarily need to have them. It's not really common to have them. But you can define one or many or more if you want to somehow simplify the initialization process. But in the end, your convenience initializer needs to call one of the designated initializers. But yeah, let's look into it more. Another important concept in Swift, it's inheritance. Only classes can inherit, so structures cannot do that. As I mentioned already, there is no default base class. So inheritance is pretty much a process when your class inherits some properties or methods, some functionality from its base class. For example, it's really common to have one base class which contains some functionality which is relevant for multiple subclasses, and this way you avoid duplicating your code. Yeah, you can override methods, properties, subscripts from the superclass. Overriding means changing its behavior. So let's look at the example on the right. We have a base class shape, which can calculate the area, and by default it just returns 0. And then we have class circle, which inherits shape. Here's the syntax, how you do that in Swift. And then you can override calculate area function and return something else. You always need to use override keyword for functions or properties which you want to change the behavior of. First, it's really helpful for yourself to see that this property or method comes from this superclass. And yeah, it also helps to avoid unintentional overriding. For example, if you would remove override keywords here and keep the function which have the same declaration is in the base class, the compiler would show an error because you either need to override it or you need to change the declaration. If you want to access some of the implementation from the base class, you can use keyword super. The same as self. Self refers to the instance of the class where you are in right now, and super would refer to the base class. And if you want to prohibit overriding a method or property or subscript, you can define it final. Here you would put just final function calculate area If you want to prohibit inheritance of a class, so if you want your shape to not be parent class to any other class, you would say final class shape. In general, it's a really good practice to keep all your classes as final as possible. So unless you actually need to inherit them, just keep them final for more predictable behavior and to avoid unintentional changes of your class by somebody else. So when you define your convenience and designated initializers, you're also going to use a delegation approach. So what is delegation? Is when you don't want to do something yourself, but you can ask somebody else who is specialized in that to do this for you. How does it work? Convenience initializer must always call either another convenience initializer or a designated one. So it always goes, how to say that, from your convenience initializer, you can only call initializers from the same class. It cannot go upwards. So a convenience initializer must call another initializer from the same class. And in the end, convenience initializer must call a designated initializer. So either immediately or through another convenience initializer. And designated initializer must call a designated initializer from the immediate superclass. So for example, we have a cat here. Let's create a base class for it. And for example, we can have this property here. Here we inherit animal class. And this won't work, yes, because you need to initialize all the properties of now both classes, because cat inherits animal. And here you need to provide value for X number. As you see, since cat doesn't introduce any other initializer, it inherits the initializer from the superclass. But if we have some other property here, let's say name, we will need to provide the initializer for it. And we also need to call the initializer from the superclass. Let's see what will happen here. Yes, as you see, you will get an error. Super init isn't called on all paths before returning from initializer. You need to do that. Let's provide a default value. Now it will be fine. So first, when you have multiple classes inheriting from one another, you need to provide the values for all the properties first. So here we need to set the name. And after that, we need to invoke the initializer from the superclass. So if we rotate it this way, it won't work. Yes, because at this point, when you call the superclass initializer, you need to make sure that your current class is properly initialized. Yeah, a simple way to remember the, actually I didn't show you the delegation that much. Let's also create a convenience initializer. This can be just empty, for example, and we provide the values here. And from the convenience initializer, you cannot, first you cannot provide values by yourself, and you cannot call superclass initializers as well, as you see. Yes, convenience initializer must always delegate to the designated or other convenience initializer from this class. So in this case, you can only do this self init. Now it works. So in this case here, when you create a get variable, now you can use either designated initializer with the name parameter, or you can use a convenience initializer. This will work too. Yeah. You can also have multiple convenience initializers. Let's say I need to come up with something. Let's put another variable. So h integer. Here you would put just some default value 5, and you can create another designated initializer. Again, you need to put a value to all the properties and then call the initializer from this superclass. And yeah, what else can we? For example, birth date. But I need to import foundation, I believe. Yeah. And here we can call the designated initializer with the age property parameter, and here you would calculate age depending on the birth date, so some calculation. As you see, the convenience initializer is not really necessary, but sometimes it can simplify the initialization process for you. Normally, you don't do many conversions or calculations in the designated initializers. Normally, they just put a value to the variable, to the property, without doing anything else. And convenience initializer often used to actually somehow simplify it for you. And a simple way to remember how you delegate the initializers is that designated initializers must always delegate up. So as you see, both of our designated initializers go up. They go the initializer from the superclass. And convenience initializers must always delegate across. So do you have any questions? Okay. So the convenience initializer must always delegate across. And as you see, we just, in both of them, we just call the initializer from this same class, either name or with either name or age property. Yeah, let's go further. Here is another example of the same thing which we did in Xcode. For example, you have a structure for a rectangle. you have the property for its origin and property for its size, and you can have multiple designated initializers to set values to these properties. For example, this one where you calculate the origin yourself from center and its size, you could have also defined it as a convenience initializer. But yeah, there is no really specific rule on how to do it better. And yeah, once you calculated everything, you just delegate the initialization process to another initializer, to this one. And the initialization in Swift goes in 2 phases. So if you have, let's say, a chain of subclasses, in the first phase, it goes up. So every time, I can show you in the code actually. So here would go the first phase. It checks that all the properties, let's remove this one, that all the properties of this class are initialized before you're allowed to call the superclass initializer. And afterwards, it goes down again, and you would be allowed to do something here, any other further setup. So let's look again in the example. So you have student athlete, you have student and person. So student athlete inherits student, and student inherits person. And before you're allowed to call the initializer student, you need to provide values for all the properties of student athlete. So if you have some sports property and you need to set a value to it, then you would say super init. Then you go to the initializer of student and you initialize the property grades. Then you can go upwards again, you call super init again, and you set first name and last name. And then the second phase begins. That's when you're allowed to do any further setup. So you go back down and you can call, for example, record grade to in the student athlete class. So let's say here, let's say we want to print something. So how it would work, when you create a cat variable, so a variable of type cat, first you would initialize name, you would set a value to name and age. Then you would go up to the base class, you would set lex number property, then you go down again and you end up here printing initialized. That's how it would work. Yeah, as you see on the diagram, first you call, for example, a convenience initializer. You delegate to the designated initializer. Here, at this point, Swift would check that you set values to all the properties, otherwise you would get an error. And then you need to call the initializer from the superclass. The same safety check would happen there as well, if there are any properties introduced by the superclass. And after that, you can customize something. So as I said, do some further setup. Yeah, and also self can be used at this point. So for example, you can say print name. At this point, you shouldn't be allowed to do that. Okay, it allows it because you already initialized it here. Yeah. But let's say if we have some method, print name, yeah, as you see, at this point, before the first phase is completed, you're not allowed to use methods of self of this class. But you would be allowed to do it in the second phase. Yeah. And yeah, as I mentioned before, you can automatically inherit the initializers, but it doesn't happen by default. You can get them inherited if you don't define any other designated initializers. And you can also inherit convenience initializers if the subclass provides an implementation of the designated initializers. So either by inheriting them, so if you don't have any initializers, but if you don't have any designated initializers defined by yourself, or overriding them. So just like a function, you can override a designated initializer. You can say, and I don't know, multiply them by 2 or something. So like any other function. Yeah, of course. So also when you override the initializers, again, you're supposed to make sure that all the properties are initialized before going up first. So that's the first phase check. So let's just put some values here. Mm-hmm. Also, initializers in Swift can be failable. It means that, for example, in the classes which require some really specific setup, and if the parameters which you provide them with do not have some valid value, you can just return nil in the initializer. You also need to declare this initializer with the question mark. This way you let the compiler know that this initializer may return nil if something goes wrong. And this way, if you use this initializer to create an instance, then it will have an optional value. Let's see how did it work. Let's remove this one. And we can say that this initializer is going to be failable. And let's say if age doesn't have a valid value, and we return nil. And then when we create a variable age -1, for example, we can just do it like this and see what happens. As you see now, the variable has value nil, although we didn't define it as optional. But since the initializer is failable, it can have nil as its value. Yeah. The opposite process of initialization is deinitialization. It happens when your instance is being removed by Swift. So it's being invoked immediately when the class instance is deallocated from the memory. And you can provide some custom actions when an instance is being deallocated using the dinit keyword. For example, if you have some class which allocates some resources, works with some files or whatever, you may want to set up a custom initializer in order to free up the resources to make sure that they do not keep allocated for no reason. And it's only available for the class type. Yeah. Let's see how it works. Let's define it somewhere here. And it will be printed here. So let's see what happens. I used the wrong. I used the wrong initializer. Let's use the main one. And then we would say, sorry, var. Yeah, so as you see, first we created get instance. After the first phase is completed and we are in the second phase of the initialization, we print its name. So here it is. And then when we assign a nil value to the get variable, the instance is being deallocated because nobody else uses this instance, and Swift removes this instance automatically. We will talk about this process in a few minutes. And yeah, after that, it's being deallocated automatically. And yeah, I have 2 small tasks related to the classes. But first, let me know if you have any questions on this topic or any other topic. Yeah, okay, then.
Yeah, I have a question. So the initializer it only comes to the initializer when the the variable is set to nil. Is it right?
Yeah, almost. So we are going to talk about the memory management in a few more minutes, but pretty much yes. So once there is no variable which refers to your instance, so when we set it to nil, we made that sure, then your instance is being deallocated. But as long as any variable refers to it, then it won't be removed from the memory.
Okay, and the different initializers always need different topics, like it's like the constructors in other languages. Is it right?
Yeah, exactly. Constructors, okay. Exactly that, yes.
Okay, thank you.
Mm-hmm. Does anybody else have questions? If no, then I would ask you to do 2 small tasks to just see yourself how the initialization process works. I will just send you here. And I would ask you to do this 2 small tasks in the playground, either in the standalone app if you prefer it, or in Xcode in the playground. And yeah, we would then do it together in 10 minutes or so. So you need to create 3 classes, A, B, and C. Each one of them inherits just one from another. And you just need to print some string before and after calling super, the initializer from the super class, and just see what happens. Same with the init. And if nobody has questions, we will meet in 10 minutes to do it together. So, has every one of you managed to complete the task? Or if you need a bit more time, it's fine too.
A few more minutes would be great.
All good. I can also go back in the slides so you can see some example. So, how is it going with the tasks?
I can't assign the C to a nil.
So you need, yeah, now let's do it together and see what went wrong. So first we define 3 classes. Then C inherits from B. and B inherits from A. In each class, we want to have initializer. And print so here let's say A. Then we need to override this initializer here. Then we always need to call super and print again. Same thing in C. And then once we create a variable of type C, we need to see what happens. Yeah, as you see, in the first phase, it goes upwards. It goes from C, then to B and A, and then it goes down. So step by step, it would be we create an instance of C, so we end up in here, print this line first, then we go to the initializer of superclass. We end up here, print another line. Here it is. Then we go again to the initializer of the superclass, end up here and print A. And then it goes down. So we end up here, print again MB, and then again down, and again C. And the second task was to implement the deinitializer. Let's do that as well. Let's also print something. Here we need to declare it as an optional C type and declare it as var so that we can change its value, the reference of in this variable. Here we would say it equals to nil. And if we run it now, you see that first the child class is the instance of the child class is deallocated, then it's superclass, and then it's superclass. So again, it goes upwards to deallocate all the objects. Does it make sense to everyone? Sounds like yes, and I guess we can continue then. And yeah, let me know if you have any questions on the initialization process.
I don't really have a question, but
Mhm.
I assigned the question mark to all initializers. Is this also okay, or is it not a good idea?
So you should use the fallible initializers when you know that something, for example, if some property is invalid, that this initializer can return nil. So in this case, it's not necessary.
Okay.
Yeah. Anybody else has questions? Okay. So now we will proceed with the properties. Just a bit, and then we would make 10 minutes pause, I think. Yeah. So properties in Swift can be of two types. stored properties and computed properties. All this time, when we were using properties in classes, we were using stored properties. So stored property means when an instance of your class is created and the memory is allocated for this instance, the value of the stored properties is stored there as well. So once the initialization process for your instance is completed, it means that all the properties have their values, and these values also stored together with the instance. So here are the examples of the stored properties. For example, file name. The stored properties can be defined as let or var. Oh, sorry. Yeah. As let or var, so they can be either mutable or immutable. The stored properties can also be lazy. That means that the value is actually not calculated during the initialization, but on the first access of it. So, for example, we have a class data manager and the storage property importer, which is declared as lazy. It means that if you create data manager instance, the data importer won't be created immediately or won't be created at all if you don't use the importer property. So let's look at the example. Let's remove this thing and say we have class data manager and some data importer. And in this case, if you create a variable data manager, the data importer will be created immediately. As I said, when the initialization process finishes, the properties need to be initialized. So that means that this initializer will be invoked as well. The instance will be created and this thing will be printed. Let's just make sure. Yes, but if you define it as lazy var, then that won't happen, as you see. But then if you access this property, it will be the value will be calculated. Yeah, as you see. So let's go back here. Yeah, that's stored properties. When you use lazy property, you cannot define it as let, because let properties, so the immutable ones, the value needs to be assigned once during the initialization, and then it cannot be modified anymore. If it's defined as a var, the value can be changed later. And the second type of properties which you can have, it's computed properties. So unlike the stored properties, computed properties values are not stored in the memory together with the instance. So when you create instance of circle, there is some memory allocated for it, and it also keeps radius value there as well, because it's stored property. But area is computed property, which means that every time you use this property, it will be calculated again. It will be computed once again, and this value will be returned every time you access it. So there is no need to store it in memory somewhere. Yeah, and they're always defined as var. And let's look at the example. For example, you could have defined data importer as computed property. And in this case, every time you access this property, it will be calculated again. So in this case, this object will be created again and again when you access the property. So, for example, in this case, it's not really a good approach to create an instance every time you access this property. But in the example here, it makes sense, especially if the radius was immutable property, if it was defined as var radius and was able to be changed all the time. It would make sense to have a computed property area which would be recalculated every time you access it, because radius can potentially be changed. Yeah. So for the computed properties, you can have defined getter. So as here, here it is pretty much a getter, and you can also have a setter. So basically, like in any other programming language, or in many of them, you can have getters and setters. So it's methods with special syntax which are used to set a value to some property or get it. Yeah, in this case, we have a setter for area. We don't really modify the value of area because it's a computed property, but we modify the value of radius by calculating it from the area. Yeah. In Swift, you can also have property observers. So once your property is modified, so once a setter is invoked, you can perform some custom actions on that. There are two observers, will set and did set. Will set is invoked right before the value is stored, and did set called immediately after. So in this case, for the radius property, you set a property observer will set, and this string will be printed every time before the value of radius is modified. So, for example, yeah, let's create the same example is in here. It was circle. And we have radius. And we want to have a setter to it, property observer. Yeah, and we can access the new value using the new value keyword. And when we create circle variable, you can define some initial radius first. So when you create an instance, in this case, the property observer won't be invoked. because it's initial value. But once you change it again, it will be invoked every time. Yeah, as you see, the string wasn't printed for the initial value, but yeah, afterwards, every time we modified the radius property, the property observer was triggered. Yeah, not called for the first initialization. And you can add it to the stored property, except for lazy, because you cannot set, or inherited property stored or computed. And yeah, it's invoked even if the new value is the same. Yeah. And we can also do did set. It's from. Yeah, so when you modify a value of radius, first the will set property observer is triggered, and we say radius value will be updated to 100. Then did set observer is invoked, and we can see that the value was updated from 10. In the did set property observer, you can access old value, and then will set its new value. Does anybody have questions regarding the property observers? Yeah, if no, then we can continue with the access control. So, like in many other programming languages, you can control which variables and which properties or classes are accessible in which areas of your project. For example, when you create some class, you wouldn't want to have all your properties visible and accessible and modifiable by everyone else. First, because it can cause some invalid state if somebody changes something by mistake. And yeah, it contradicts just the encapsulation approach. Yeah, access control used to restrict access to parts of the code, hide the implementation details, and specify preferred interface through which your code should be used. Access levels can be assigned to types, properties, methods, initializers, and subscripts belonging to classes, structures, and enumerations. So here is an example. We continue with the circle. And we have two private methods to calculate area and radius. So as you see, once we modify the area property, we want to calculate radius out of it, and we moved the code to calculate it to in a separate method. And once it's declared as private, you cannot access it outside of the scope. So in this case, scope would be this structure. So as you see, when you create a variable of type circle and try to invoke the private method, the compiler won't let you do that because it is inaccessible. There are 5 there are 5 access levels in Swift. The most broad one is open. It means that your property method or class is visible from everywhere, so not only from your module, from your project, but from pretty much any code which uses your code. And the class, for example, if you define open class, it can also be inherited, and its properties can be overridden outside of your module. Then goes public, really similar to open, but all your public classes outside of your module cannot be inherited. Yeah, otherwise they're really similar. The default value would be internal, so that your classes or struct or whatever is usable just inside the module. Then goes file private. It means that, yeah, you have one file, and everything inside this file can see and access this property. And you can also have multiple classes or multiple structures in one file. It means that they would be able to access each other. And then goes private. It means that it won't be accessible outside of the class or structure. So if here we say private, that won't work anymore. Yeah. Yeah, as you say, because of the private protection level, the radius is not, yeah, even initializer is not accessible because the radius is not public. Let's go back for a second. Do you have any questions regarding the access levels?
If you don't set any access levels, what will be used?
It is just internal.
Okay.
So inside your module, it will be accessible. And yeah, as I mentioned, you should try to keep your classes as final as possible, and also try to keep your properties, methods, all of that as private as possible. So you should make something public if you expect other users, other developers to use it, and you yeah, specifically expect them to use it this way and not any other way. So I try to keep stuff which is not supposed to be public, try to keep it private. Yeah, and then we can start with the protocols. In some other programming languages, it can be also called interface. So in Java, it would be interface, in Swift, it is called protocols, but the idea is pretty much the same. Protocol defines a blueprint of methods or properties for your class. So basically, in the protocol, you just say what your class is supposed to be able to do. Yeah, class or structure. What it is supposed to do, which functionality it's supposed to provide, but you don't tell in which way. So I like to give an example. Imagine an ATM. So regardless in which country you are and which language they speak there or which banks they have there, you can just go to any ATM and you would expect exactly the same functionality. You would see the buttons to put the PIN code. You would see some small screen to see the information, and you would see the how to say it, the thingy where the money would come from and where you can put your credit card. So yeah, regardless of what bank provides this ATM, it would work exactly the same way everywhere. So pretty much you just interact with the protocol. You don't know how exactly it works. You are not aware of any implementation. You just know that you can get money out of it. You can put credit card there. You can put your PIN code there and stuff like that. So that would be protocol. Yeah. As I mentioned, it describes what an implementation will look like, and it can be adopted by class, structure, or enumeration to provide an actual implementation. Any type that satisfies the requirements of a protocol is set to conform to that protocol. So if you hear that somebody says that some class conforms to that protocol, yeah, it means that it implements it. Protocols can require that conforming types have specific instance properties, so instance methods, type methods. Yeah, you may be more familiar with the static, non-static terminology. So in Swift, it's often referred as instance methods and type methods. So type methods are static, and instance methods are non-static. So for example, this function random is instance method. And if here there was a static keyword, it would be type method. Operators and subscripts, yeah. So let's play around a bit with the protocols. Let's use the same random number generator. Yeah, random. Yeah, so as you see, when you declare a protocol, you just define the name of the function and return type. Also, you can define parameters if you need, but you don't provide any implementation. So if you try, it will tell you that you shouldn't do that. Yeah, protocol methods must not have bodies. And then we can have multiple implementations of it. Let's say yeah, random number generator. And now we need to implement the method. Yes, the compiler will always offer you to do that. And here you can do that. Let's just return unknown 5, 7. And then, for example, if you have, you can define a variable for the collection of the protocol types. And then you can append it with any instance of any class which conforms, or a class or structure or enumeration which conforms to this protocol. So let's say we have multiple. And we can provide any of them. Let's say 3. Yeah, and as you see, all of them will work for this array. Let's see how it looks now. Yeah, all of them are appended to the random number generator array. In your protocol, you can also require all the classes or structures which implemented also to have some properties. For example, let's say, yeah, when you define a property in the protocol, you always define it as var. Let's say no name. And you want to say that this property needs to be gettable. So that's how the syntax works. Then your compiler will ask you to provide the implementation. And here you will also need to have initializers for those. You can also, for example, if you define it only as gettable, you can also make it a computed property. And then you don't need initializer for it. Yeah, but if you require in your protocol to be for it to be gettable and settable, then you either need to have it as mutable property, so var, or you need to provide both getters and setters. So let's say if we put that here, it will tell you that, yeah, it doesn't conform to the protocol. As you remember, conformance to the protocol means that it fits all the requirements of the protocol. In this case, it doesn't. Here, it asks you to make it settable as well. So now it would work because in the protocol we require for it to have getter and setter. In this case, we define them. Yeah, it's either mutable property or it has getter and setter. Yeah, like this. And I believe we can take 10 minutes pause if nobody minds, and we will see each other in 10 minutes, so 10:30.
All right.
See you. So, hello again. I guess we can continue where we stopped. And that would be enumerations. So another really interesting type in Swift, it's enumerations. They're also value type, same as structures or tuples, as you remember. So in what way enumerations are special is that a variable of an enumeration type can have only value of the ones which you define in the cases of this enum. So it cannot have some invalid value or something what is not defined in the class. So for example, if you have a structure type with many properties, the variable of this type can be pretty much anything with any values set to the properties of the structure. But with the enums, it's pretty much just one of the cases which you defined. That's why it's really common to use enums for the state, because normally when you have some state, let's say on the screen, so it can be either loading, either empty, error, or it received a successful response from the server, so it's loaded. And it can be either one of them. It can be two at the same time or neither of them. And it's really convenient to use them for a so-called state machine. So you can define which state is initial and how one state can transition into another state and how you react on this state change. But yeah, if you have more time left later, we could talk about state machines. It's a really common design pattern. Yeah, so how you declare an enum. Instead of class or struct keyword, to use enum, then you define its name. And then in its body, you need to put as many cases as you need. It can be anything from 0 to as many as you want. Why would you use enum with 0 cases? It is a common way to kind of create a namespace. So, for example, let's go back to Xcode and remove all of that. And define enum, let's say math. And then here you would put all the methods which do any mathematical calculations. Let's say square. Return. Yeah. So later on, when you're going to use this function, you would just say square of 2, for example. Actually, that's not. Yeah, of course. I need to declare it as a static. Otherwise, I would need an instance of it. So yeah, as I said, it's a really common way to create a namespace. So to make your functions, for example, belong to one, let's say not instance, but just a group of something what is used for the same goal. It's also convenient to use it because if you declare it as a static, and if it's inside enum, then you cannot accidentally create an instance of this enum. Yeah, because if you did it like this, if you use class to use it as a namespace, then you can accidentally create an instance of it, and you may not want it in this specific case. That's why, yeah, enums are convenient. You cannot create an instance of it except for the cases which you define yourself. So if it is a state, so let's say empty and loading. Let's have just two states. It means that this enum will have only two instances ever. You cannot create any other instance. So you cannot say, for example, state cannot be constructed because it has no accessible initializers. The only instances which you can have, it's either empty or loading. You can also use them with just dot, like this. So if the compiler knows already the type of the variable, here we defined it, we can just omit the enum name, so the class name. We can just use the instance name immediately. Also, in Swift, enums can have a raw value. So, for example, let's say it's not a state, but server response. Or let's say response code and code 404, code 20, 200. And for example, you want to have an integer value which corresponds to this code, then you can say that your enum inherits from int. And then you would say that code 404 equals to 404, and code 200 equals 200. Yes. And later on, let's say you have a variable for the response code. And to access the raw value of it, so the number behind, you can just use the raw value property. In this case, you would then make it int, and here you need to define the enum name. Yeah, like this. And for example, if you want to have just different properties for each of the instance, and then it is called associated values. So your enums can have associated values. For example, it won't have a raw value anymore, but let's say it would be what is an example here? Yeah, let's go back to the state. So state. Let's say case empty and case error. And when an error occurs, for example, we want to have some string representation of this error. In this case, when you have a variable state, you can either say that it is empty or it is an error, and then you need to provide a value to the associated value of this enum case. Let's say no internet connection. And then if you want to retrieve these associated values, you can do it in switch. So you have state, and then you say if case, if it's empty, you just print empty, and if it is like this, so as you see, when you have an enum instance, an enum variable, from an enum which can have associated values, to retrieve them easily, you can use switch. And to actually bind it to the variable, you can use syntax like this. First, you need to use the name of the case, and then you define a variable which will, to which the value of this associated value will be bound. And if I said that it's empty, yeah, this will be executed. There can be also more cases. Let's say success. With some data, let's say we have some user data. So this state will transition to a success state if the server responded with the valid user data. So let's say it will be success. And we always need to handle all the cases. Again, we bind it to a user variable so that we can access it here. Yeah, so since now our variable has success case as its value, we can print our username. So what did I miss? Yeah, it lets you work with the value in the type safe way. Type safe because you cannot assign anything outside of the cases which you provide yourself in your enum. It cannot be anything else. And if they have a raw value, it can be a string character or any integer or floating point type. So basically you can use just primitive type for that. Then you can have associated values. Yeah, type and amount of them can be different. So it can be also not just one, it can be, I don't know, let's say server response we would put here, so it's an integer. And when we say that the case is success, we also need to provide integer here. And we can either bind it to another variable here, or we can just ignore it if we don't need it. Like this. And yeah, you can retrieve it in a switch. And I have one small task on enumerations. It's the last one for today, I promise. Just a second. So here it is. I will just quickly show you. So you have an enum there. Oh, it doesn't look nice, huh? Whatever. So you have an enum for a coin, and it has a raw value, integer, penny, nickel, dime, and quarter. Each of them have a different value. And then you have an array of coins. You see, different ones. You can use each of them multiple times. And your task would be to write a function where you can pass an array, and it would calculate the total amount of your coins. So you would declare a function like sum up, for example, coins. It needs to receive the array of coins, and it would return integer, so sum of all of them. Yeah, and here you would need to calculate their total amount and print it. So for now, I will return 0 here. Yeah. So you would need to implement the sum function. And I think, yeah, I think we could take 15 minutes for that. And then after that, we would solve it together. So yeah, at 11. Please let me know if you have questions to this task. Does it make sense to all of you? Is it clear?
Yes, for me it's clear.
Sounds good. So how is it going with the task?
You said.
I wanted to say I don't know about the others, but I finished it.
Did you get a value?
Yep,
What is it?
77.
Oh, great job. So does anybody else have need more time to complete the task? Maybe a few more minutes. Okay, let's just wait a few more minutes and then we will solve the task together. So now let's solve the task together. So we were supposed to write a function which sums up the raw value of the enum instances. So in this case, we have the array of coins, what we could do here is to use reduce function. So reduce function is really useful when you want to accumulate some value out of all the elements of your collection. So initial result would be 0, and then we would produce the next result. So yeah, that's how it works. Your reduce function, first parameter, it's the initial value for your accumulated value. So it's if you want to sum the elements, normally it's 0, and then it receives a closure with 2 parameters. The first one, it's partial result. So for example, so this closure will be executed for each element of the collection, and this partial result will have a value of the previous elements to this element summed. So for example, when this closure is executed for the quarter, the result will have a value of penny, which is 1. And then when the closure is executed for nickel, the result would have a value of sum of these previous 2, so which would be 26. And I think we can even see it in, no, it's not what I wanted. Let's just print. So as you see, at first it's 0 when it's executed for penny, then it's 1, then it's 26, and yeah. In the end, we get the sum of all of them. Does it make sense to everyone, or somebody has a questions? Yeah, then we can continue. Yeah, the next topic would be generics. Just a second. Generics. They are really helpful in order to write reusable code, which can work with multiple types. In a lot of programming languages, there are the same or similar implementations of generics. For example, the collections, so arrays, sets, dictionaries, and Swift are generic collections. That's how, for example, array is declared in Swift standard library. So in these brackets, the element is the generic. It means that this generic type can be replaced by any other type. So for example, if we go back to the, yeah, for example, here we have an array. So it can, yeah, basically it is, you can also say, yeah, like this. So it would work as well. We say that it is an array and generic type is coin. Yeah. So you can use any word for the generic type. Often T is used just for the type really commonly, but you can use any other name to make it more readable. Especially it's important to have more descriptive names if you have multiple generics. So for example, let's remove this. And let's say we have stack, like on the example in the slides. And in these brackets, we define the name of the generic which we are going to use for this structure. So let's say element. And once we defined this type in the class struct declaration, we will refer everywhere inside the structure to it as element. We cannot use anything else. So we would say that stack contains a private array of elements. Yeah, so if you named it T, it would be T. So the whole idea of stack is that you cannot use it as an array, for example, access elements by index or something. You can only push the elements into it, and they're stacked on top of each other. And then to retrieve the elements, you need to pop them, and the last element which was added will be removed the first until all of them are removed. So let's implement that. Yeah. Yeah, also important moment, we need to define, we need to declare the methods of the struct which are somehow modify the properties of the struct. We need to define them as mutating. For class, you don't need to do that. So let's first implement push. T. I think it's drop last. I'll remove last. Yeah. So, and later on, you can use this structure with any type you want. So, for example, you can create stack of integers, or you can create string stack. So as you see, both types of declaration of the generic types of variables are valid. So you either need to say that it's integer here, or when you create an instance. But once you declare that it's integer, you don't need to duplicate it. So you see, it's not necessary. Even, yeah, it should be integer. Yeah, but not necessary to duplicate it. And then, yeah, as I mentioned, Swift is a type-safe language, and it won't let you put a value of the wrong type. So since your variable is declared of type stack int, the compiler remembers that and won't allow you to put a string there. As you see. what you also can do is to, it's on the, I thought there was next slide. Yeah, here. You can also put bounds to your generic types. So for example, you want to say that your stack can only accept types which are, for example, numeric. Right? Yeah. So this way, this stack which contains integers will work fine with that because int is numeric as well, but it won't work with strings. So it's you can use it for the case when you want to limit the types which should be accepted by your class. Do you have any questions to that? Sounds good. Then we will quickly look at extensions. Really convenient feature from Swift is that, for example, you have a structure, and you can provide some functionality, add some functionality to your class structure or enumeration using extensions. And you can add extensions not only to your own types, but any other types which you didn't write. And these extensions can be also stored in different files. So for example, you would write extension for your stack and add some function like, I just need it. Let's make it internal. And then we can provide a variable size. Like this. And then when you have a stack, let's set something. And then we can use the property which we added in the extension. As here, it's 3. Also, extensions are often used to split your class a bit. So for example, if your class implements conforms to some protocol, you would put it into extension just to improve the readability. But in general, if you have a larger project and yeah, the class is huge, don't overdo with the extensions. But otherwise, they are nice to structure your code. So yeah, you can add computed properties, computed static properties, methods, initializers, subscripts, nested types, and it can conform to a protocol. Yeah, really convenient. And as I mentioned, you can extend also the types which don't belong to you. So for example, string, and you would declare a function, for example, print, which will just print itself. So in this string. And when you have some string, you can say print. Something goes wrong. Okay, let's just name it differently, I think. Self. Yeah, now it works. So here you can add the additional functionality to pretty much anything. Also, important to remember about the access access modifiers. So, for example, if something is private, you won't have access to it. Actually, in this case, you do. But let's say in the string type, I guess since the defined clause, I guess it's fine. So let's say something private. Okay. Yeah, later on we will try out in the actual project, not in the playground. So let's go further. And yeah, as I mentioned, we are going to talk about the memory management in Swift. So different languages offer different solution to the memory management. In Swift, you use automatic reference counting. So back then, when Swift was just introduced, or everyone used Objective-C, you were supposed to count references yourself. What does it mean? Is that every time you create an instance of some class and another variable refers to this instance, it means that the reference count should be incremented. And as long as your instance is referred more than 0 times, so or once or more, it shouldn't be removed, because otherwise there could be some unexpected behavior that you're trying to access instance which doesn't exist anymore. Yeah, and back then you needed to do it by yourself. You needed to count it by yourself in order for Swift to remove this instance for you. And now it's done automatically. So every time you create a variable, so for example, this instance have a reference number 1, as long as this variable refers to it. But if we say that it's nullable, optional, sorry. And then we say that it equals to nil. The reference count goes to 0 for this instance. And at this point, it will be removed automatically by Swift. Yeah. You can also, of course, have multiple variables which refer to the same instance. So, for example, now these two variables share the same instance, so they have reference to the same stack. After you after you created this variable which refers to the stack, the reference count would be 2. So it means that 2 variables need this instance, and the stack won't be removed unless these variables either refer to some other instance, or refer to nil, or they are removed themselves. And at this point, when we assign nil to the first variable, the reference count goes to 1. And once we make the second one equal nil, the reference count is 0, and this instance will be removed from the memory. Yeah, so the automatic reference counting tracks and manages your app's memory usage, and it allocates a chunk of memory to store the information about the type, and it stores the reference count, which it will count for you automatically. And when the instance is no longer needed, it will free up the memory. And as long as there is at least one active reference, the instance won't be deallocated. What you need to be careful. So automatic reference counting is extremely convenient, because it does a lot of work for you, and it works really efficient and fast. But unfortunately, it cannot prevent strong reference cycles. What does it mean? For example, let's create new classes. Let's say it would be an apartment. And a person. And a person can have an apartment. And apartment can have a tenant, which is a person. And so once you create an instance, so it's a person. So let's make it var. So we create an apartment, and then it equals to this person. So what we created here is basically a strong reference cycle, because both instances refer to each other. It means that at this point, the the reference count for both of them is 1. The reference count 1 is for both of them, and basically in this case, the automatic the IRC will never remove these 2 instances, because they refer to each other, and the instances will never be deallocated. And we will look into the solution. So when you declare properties this way, just with no other keyword, it means that the reference is strong. So it actually increments the reference count, and as long as this property refers to some instance, this instance won't be deallocated. The solution would be to use either weak or unowned reference. It means in both of these cases, it wouldn't prevent the IRC from removing the instance from the memory. And we will see how it works right now. There is a small difference between them, and we will see it in the next slide. So here is an example of what we did in Xcode. So as you see, since these instances refer to each other, they have strong references to each other, they are not going to be removed. Actually, it would be better if I do it like this. To demonstrate it better, so we create an apartment. We pass this apartment here. So some variables. Yeah, we can just like this. Yeah. So now basically we have strong references to these instances, and they have strong references to each other. So the reference number would be 2 for both of them. Let's also implement the dinit, deinitializer for both of them. And you will see here, once we assign nil to both variables, yeah, nothing happens. So the instances were never deallocated. They are still in the memory. Yeah, it's not really a good way to manage memory because, yeah, the more resources you never deallocate, the more memory it takes, and yeah, it's just not efficient to waste it this way. Yeah, the solution would be, as I said, to use unowned or weak references, and let's see how it would work. For example, yeah, here it is. For example, we can make the reference to the person in the apartment instance weak, and then it would work. Yeah, let's just try it in the code. So we can make it weak. And let's see what happens. No, it didn't work. So apartment, no person got allocated. No, sent to nil, and
Shouldn't be the string wrapped in a print function?
oh my god, yeah, you're right. So, yeah, it works. So as you see, once you assign nil to person variable, it is being deallocated because this reference do not keep the strong reference to it anymore. So it will just have value nil, and the person gets deallocated. And then since apartment also doesn't have any strong references to itself. When the person is deallocated, the apartment is deallocated as well. So as you see, although we assigned nil value first to the apartment, person is being deallocated first. So for example, if we comment this out, nothing is going to be deallocated. Yeah, because although the apartment, although this variable doesn't have a reference anymore, but the person instance still refers to this apartment instance, and it's not going to be deallocated because the reference is strong. Yeah. Mm-hmm. We can also make it, another example, unowned. Would work the same way. The only difference is that weak reference is always supposed to be optional. The unowned one can be not optional, but then you need to be really careful because you will need to check if it's not nil yourself, and yeah, the compiler won't prevent you from making a mistake. So be really careful with unknown. Weak is just easier to handle. Yeah, using a node reference only when you're sure that the reference always refers to an instance that hasn't been deallocated, and if you try to access it, you will get a runtime error. Another case when you can get a reference cycle is when you use closures. You may remember from the previous lecture that closures can capture the references from outside, and that can cause an issue as well. So let's also, let's not type it, but look at this example. So you have a class which has a closure variable. So as you see, it is a strong reference to this closure, and closure in itself captures self in its body. So self is self keyword means the reference to the instance of the outside class. So basically, the class refers to the closure, has a strong reference to the closure, and the closure has strong reference to self. That means that, again, neither the instance nor the closure will be never deallocated because of that. Another solution would be, of course, declare the, actually, I think we didn't tell you about this syntax yet, or maybe Ralph told you. So when you use a closure, you can declare self either unowned or weak inside this closure in order to not to have a strong reference to this instance. And this way, it's not going to be a reference cycle, and ARC will be able to remove both instances. Yeah, let's actually try to do it if we still have time. Yeah, but so it's class HTML element. Which has a closure. And it returns string. And yeah, we don't want to do much, but let's just use self in some way. So we would have What was their name? And we want to access name and I don't know, print it. And you also need to, oh, let's just return it. Oh, yeah, I forgot equals. Missing something. Right. Just a second. Morning is hard. I exactly cannot find self in this code. Of course, it needs to be lazy because, yeah, if you don't define it as lazy, then we cannot access self because then the value will be evaluated during the initialization, and before the first phase of the initialization is completed, we cannot access self. Yeah, of course. And then, yeah, once we create a variable of this type, we have a strong reference cycle because this reference strongly refers to disclosure, and disclosure strongly refers to the instance. What you can do is define self as weak inside this variable and inside disclosure, and then the compiler will force you to unwrap it before using it. Yeah, like this. Or you can also make it unowned, and then you don't need to unwrap it, but you need to be careful with that. If the reference will be deallocated and you invoke disclosure afterwards, it will crash your program. Some other programming languages offer other solutions to the memory management problem. One of them could be a garbage collector. Both of them are extremely convenient and have their own advantages and disadvantages. So, for example, Java uses garbage collector. The big disadvantage of ARC would be that it cannot prevent retain cycles. That's why you need to be careful yourself to not introduce them into your code. And garbage collector actually can prevent them. So garbage collector works differently. It's pretty much a heavy process which runs in the background and checks all the entire object refs and it is able to prevent retain cycles. It will just remove them altogether. It is easier to use because you don't need to do any memory management work. The only disadvantage is that it takes more resources, and creators of ARC decided that it is not worth it for, especially for mobile devices, to not take up these resources. But otherwise, both of them are valid and good options. Do you have any questions on that? I think we actually have not that much time left. Yeah, 10 minutes or so, I think. What is the next one would be? Yeah, maybe let's not start a new topic for today anymore. Do you have any questions on the topics which we discussed today? So protocols, enums, access control, properties. Is everything clear, and does everything make sense to you?
I have a question. On the generic slide, we used mutating functions.
Yeah.
What is this?
So as you remember, as you may remember, structure is a value type which pretty much cannot be modified, but can be copied. And in order to be able to modify something inside the body of a function, it needs to be declared mutating. Otherwise, no, let's start a bit from the beginning. So when you change any property of a value type, so structure in this case, it is equal to the case when you assigned a whole new instance to this variable. And if the function is not declared as mutating, it cannot do that. So we had, let's quickly go in the beginning where we had variables. So here it is. Yeah, once we modify the property, it is equal to assigning a new instance with the new property. And in order for the function to be able to change it, it needs to be declared as mutating. So let's quickly look. Do we have a structure here? No, we don't. So let's say we have structure user with age, whatever. And then, yeah, in order to be able to modify it in the function, let's see what happens now. Yeah, so the left side of mutating operator is mutable. So self. So when you're inside class or a struct, you always have self as a reference to the outside class or structure, and by default, the structure is not mutable. That's why you cannot change anything about that. But once you declare it as mutating, the self which this function receives is mutable, and it can create a new instance to assign to this self. if it makes sense.
Yeah, thank you.
Does anybody else have questions? And yeah, if no, I guess we can then finish. Yeah, what I also wanted to tell you, since we still didn't complete the slide, the Swift slide deck, you don't need to finish the Swift exercises until the next lecture. You can start with them if you want, but yeah, you can also start with them once we finish the whole slide deck. Also, Ralph told me that you were asking regarding the project, whether you can do it together. Not sure if it would make sense for us in this case, because once you do it all together, not all together, but in a few people group, that means that you need to produce more result. So instead of, let's say, making 3 screens app, you would need to make more, like, I don't know, 9 screens, which makes it more complicated. It also makes it more complicated for us to evaluate this work, if it makes sense to you. I hope it's fine for everyone. Because yeah, it would be nice if every one of you can actually create an app on his own and produce the actual result.
Okay, and when should we know what kind of app we're going to make? Or I mean,
I would say now you can just think of the ideas which you can do, but you would start working on that only after we learn about UIKit. So then you would be able to actually create an app. I would say the app can be pretty much anything. For example, it can be a tool which somehow helps you in your everyday life, or I don't know, it can, for example, gather news from multiple sources and show in a convenient way for you, and you can, I don't know, bookmark them and read them later or something like that. Or yeah, anything, something what helps you in everyday life. Would be nice, of course, if it can perform some requests to the server, maybe save something locally, just to show that you are able to apply the knowledge gained.
okay, so the scope does not need to be really big.
No.
So okay, so something like a tic-tac-toe would also be fine, or
Like what? Sorry.
like a tic-tac-toe, just for an example.
Yeah, just something small, so you would be able to show different things which you learned, but it doesn't need to be, how to say that? It would be nice if you can show various things which you learned, but they don't need to be big. Yeah.
All right.
Yeah. Yeah. If nobody else has any questions, I guess we can finish for today, and you will have the next lecture with Ralph. I'm not sure when, but I guess it's him next time. And I will see you, I think, next Friday. See you.